let's go ahead and before we start talking about any math, let's just kind of go through the logistics of the class. They're pretty straightforward, but just so that everyone's on the same page, let's go ahead and look at Canvas for a minute here. I'm not bad. In case I didn't say it already, my name is James. You are welcome to call me James. But if that is not comfortable for you, you're also welcome to call me Mr. Parmenter or teacher or other words that mean teacher. Like you could call me professor, but I'm not a professor. So, but I know people like to use that word, so that's fine as well. Whatever you like, James is the best, but other things are totally cool as well. So Co-17C, that's us right there. Let's go ahead and take a look. See if we can see some things that are interesting. So let's start with the syllabus. Just so you can see all the things here. You can certainly attend class via Zoom if you wish to. It's totally an option every class. Perfectly fine. Ways to reach me. The best is probably email. If you think I might be in my office and it's really urgent, you need to call me I don't know why you would need to call me for some reason urgently, but if you did for some reason need to call me urgently, you are welcome to. My office, you're also welcome to come by. I have office hours at these times and places. Mondays and Wednesdays starting next week in math drop-in in Shields Library from 10 to 12. Mondays and Wednesdays from 2 to 3, and Tuesdays and Thursdays from 9 to 10:30 in C class, which is the Centro over in the and that is starting this week. So the drop-in office hours are not until next week, but the ones that are in C class and the ones that are in CADS are starting today. So I'll be over in C class after class today from 2 to 3:30 if you want some help with math. That says 2 to 3. I feel like it was 2. I'll have to double check that. I thought I had 2 to 3:30 on my schedule, but I will double check. It's either 2 to 3 or 2 to 3:30. And then Tuesdays and Thursdays from 2:40 to 4, right? 2:30. UC Davis is 2:40 because we start 10 minutes after. Grading. So all of you should have received an email from me sometime over the weekend or today, letting you know that you are either actually enrolled in this course and need to do all the things to pass the class, or B, not actually enrolled in this course and you don't really need to do the things, but I'd still love it if you did the things. The things being filling out the attendance form, which we'll talk about in a minute, and doing the weekly reflections. This is all you have to do to pass this class. Filling out the attendance form is pretty easy. You just go to the link, which we'll talk about in a minute, and fill out the things. Doing the reflections is also super duper easy. It's like, how is class going this week? What did you do? What's your favorite movie? No math questions, just easy things. Maybe where's a good spot to eat in Davis or somewhere else. Anyway, I would love for you to do them, but if you're not actually enrolled, they're not required. If you are enrolled, they kind of are required. So you need to do them. Also, we'll get to that in a minute here. Let's see here. What else? Yeah, so I guess we can go to here. Let's look at the weekly reflections for just a second. Here's the first one, which is already due, but you can still do it. But they're not open forever. This one's only open until January 12th, so you need to do it before then. Yeah, I don't think I can actually like do the thing, but you basically just write some words. Like I'm actually like, I don't know if I can do this as a not student. Like I don't think I can actually see the assignment, but I think some of you have already done it. It's really just like typing answers to these questions. What name do you like to go by? What's your hometown or place that you come from, et cetera, et cetera, et cetera, right there. I think just easy questions to answer. Question.
I'm enrolled, but I haven't had access to the campus.
Yeah, really? That is concerning. Well, shit. I definitely publish. So does anybody have access to the Canvas page? No. Okay. What is up with that? Well, damn. Yeah. Interesting. And you for sure registered with the CRN. Okay. All right. That just might have been an oversight on my part because I was literally just looking at the list of people. Well, damn, that's concerning that none of you can see the canvas. Let's go back to my dashboard for a second here. I don't think there is there any. Yeah, I don't that well, no, I imagine if all of you don't, then it's fairly likely that nobody does. Yeah, there's just me. Well, but some of you are actually enrolled, right? And those of you also can't see the canvas, right? So I don't think it's an issue of whether or not you filled out, like whether or not you're enrolled or whether or not you did the Google form. There's some other issue going on here, which is, and let me, well, now I'm like, what's the problem? Definitely the course is published, which is the only thing I can think of that would really, That's, well, I'll try and figure that out soon, but not right this minute in class because it seems like not the best use of our time right now. But yeah, that is worrying. Okay then. So, well, yeah, that's what I'll be doing after class today. Anyway, let's still talk about what's on Canvas so you can see all the things at least here. So back to the syllabus. Oh, actually, yeah. So the reflections. Okay, yeah. So reflections are, once you have access to Canvas, easy to do. What else is on the syllabus here? Oh yeah, the other things. So let's see. So grading. So we have the weekly reflections. The attendance form, you don't have to have access to Canvas to actually get to. It's not on Canvas. So here's the form. It's not too terrible. You write in your email. I can write in my email. I can even fill it out. My ID number, 995-312-456. That's not really my ID. What was my ID? Gosh. I think I might be able to remember it if I really tried hard to remember my student at UC Davis ID number from too many years ago. What class? Co-17C. How did you attend? Either live in person or live virtually, or you watch the recording later. All three ways are totally fine ways of quote unquote attending class. The only requirement that I have is that you need to do it within, what I say here, I think 2 weeks of the class date. Yeah, 14 days. So if you were making up today's class, you would need to do it by January 22nd and fill out the form by January 22nd. I just don't want people filling them like a bunch of that at the end of the quarter because it always tends to be a thing like in the quarter, people are like, oh, I forgot to do it. And you do like it's like, just do it as we go along. It's not hard to do. And then the date for the class that you're attending. So if you were watching the video a week from now, you would still enter the date of today because today's class is the class you're attending for. So I would enter 01/08/2024 and do type all 4 digits because if you don't, it comes up as just like the year like 24 or the year, right? So I have to like, they'll get all out of order. So fill them out completely and it's not hard and I'll submit it and then, oh, I forgot my name. Do you write your name? Do you write your first name first, your second name second? No commas, no other unnecessary things. And then you submit it and it goes to a Google Sheet where I then take the thing from the Google Sheet and put it into Canvas to show you what your attendance grade looks like. Again, it's really not that big a deal, but if you're enrolled in the or officially registered for the class through Schedule Builder and you do want to pass to get the 1 unit, you do need to do the things so that you can get the unit. For those of you that are not officially enrolled, I still really, really, really would like it if you would please fill out the attendance form because we do take and track our attendance data, and that has some small part to do with funding for our department. So if you could all please fill it out so our department can get funded and have more money to provide more services, that would be lovely. All right, what else here? That's grading. If you're absent, you can make up a class by watching the video later. It's not that big a deal. What else here? Something outside the class is impacting your success. Please don't hesitate to come talk to me. I am a pretty helpful resource. If something is said in class by anyone, including me, that makes you uncomfortable, you can talk about it with me. Again, I'm not anticipating any of these things, but I'm just covering our bases here. You can also use this feedback form if it's about me specifically. If I said something terrible, you're like, James, it's awful. I need to tell someone about this. Again, not anticipating that, but you never know. It's something, I don't know. I don't really like it. You never know. I don't, here's all your resources. I don't try to say terrible things ever, but maybe I would say something stupid. I don't know. Not really. I'm not dumb like that. It's just some people are. So here's all your resources. And maybe some other teacher is saying something terrible that you can also go here and use that. Again, hopefully not. Our classes now at these times, you know it because you're here. I'm going to do examples. You're going to try practicing some examples. I really do encourage you to come prepared to like write stuff down because some of the time I will try, especially extra, oh, shit. I just realized no one's on Zoom probably because no one can access the canvas. Fuck. Well, shit. We'll figure that. Sorry for the swearing, but you know, like I don't. You're all adults. You can handle it. We'll have to. Yeah. Damn. All right. Well, we'll fix that later. Can't fix it right now. So yeah, you can come on Zoom, assuming you have access to it. I'll have to. I guess I should also post things. I also made a Discord for the class, which I imagine which I posted in the Canvas, which is not helpful because no one has access to the Canvas. But if one of you has access to the Zoom, you can visit to the Discord. You can share it with other people. I will also try to share it via email, I guess, because you are getting the emails I send you. Great. I'm really, yeah, perturbed by this Canvas situation here. Let's see what else. Zoom, you all know how to use Zoom. Some notes. It's worth one workload unit if you're officially enrolled. I've always tried to get people to use the discussion tab to like ask questions and have other people answer them. It almost never works out. It's kind of like Discord, but like just on Canvas where people could ask questions and I could respond, or you could respond. What's nice about Canvas is you can type math nicely. Like I can do a lot of cool mathy typing that I can't really do. Actually, that's not true. That's why I set up a Discord server this quarter, because I set it up so I could type math, because I can have like a math type chat bot thing. So you can ask questions on Discord too, and I can probably answer them using nice looking math type as opposed to terrible looking not math type. You should be studying a lot. Successful students usually spend 10 to 20 hours per week doing homework. For this class, I guess that seems like no, that's not that. I mean, it's a lot, but it's reasonable as far as how much work this class takes. Where can you get more help? My office hours. There's tutoring from other AATC specialists and student tutors as well. I imagine many of you being in 17C, having taken other math classes already, probably know where your resources are, but here is where you can find them as well. There's also the drop-in tutoring starting, I think it starts Sunday, but if it doesn't start Sunday, it definitely starts Monday of next week at these times, Monday through Thursday, 10 to 5, Friday, 10 to 1, Sunday, 3 to 7. And of course, you yourselves are great resources for each other. You should definitely get to know each other. Maybe not today, but before next class, before class starts, maybe talk to someone. Maybe I'll make you do it next class. So you're ready. You might have to talk to people. Okay, so that's the syllabus. There's not a lot to it. Really, fill out the attendance form, do the reflections once you have access to Canvas. But the place you'll probably actually go in Canvas once you have access to it is the modules. That's where I think all the important information is posted. You can't see this yet, but that's the course evaluation that I'll ask you all to fill out at the end of the quarter. I would appreciate you all filling it out at the end of the quarter. You can see again where my office hours are, a link to the attendance form, a link to the Zoom, a link to the YouTube playlist where all these videos will get posted and all the previous quarter 17C videos are posted. So if you want to go look for older videos of me saying the same things I'm saying this quarter, you certainly can. Last quarter, it was a different teacher. Have you all had your actual 17C class yet? With Saito's house? Yeah, okay. He hasn't added me to Canvas yet, but hopefully he will soon. Is he using Canvas, I should ask? Okay, all right. I mean, I figured he was, but not everybody uses Canvas, so. Okay, well, hopefully I'll get on there soon. Is he using web work? Is he assigning homework at all? It's optional. Okay, well, I'll have to, yeah. All right, I'll find out about that and maybe I'll look at the assignments. Maybe if you guys want, you could turn it in to me. I could grade it.
Based on the syllabus, it's 40% weekly quizzes starting next week.
All right.
A midterm.
Okay, and are the quizzes on?
It's like they're in discussion.
Oh, okay. All right. Okay, cool. I mean, I mean, I like quizzes. They are not as high stakes as a midterm exam. If you keep up with the material, you should be relatively prepared for them. Should be, I don't know. I feel like that's a way to try and give you a lot of opportunities to do well in the class. Like I think that's trying to make it so it's easy to do, but not like it's too easy. Grant's website is always a great resource. I would point everyone there all the time. There's lots of good handouts about various things. I will probably also use them too. This is something we were doing a while ago. There are still some videos up here of various specialists. They're shorter videos of just various topics, and they're organized by the chapters of the book. So in fact, we can go look there for a second if you want. Oh no, not there. Yeah. And look here just for a second. If you're looking for other stuff, it's just all the sections that we cover in this. And then eventually the videos will actually load. You can see them there. Oh yeah, look. Videos on functions, domain, range, limits, etc. And there's some of me with a beard. Oh yeah, way back when. And Grant, and maybe Sarah as well, somewhere down. So lots of resources, lots of places to get extra instruction. I would encourage you to check them out as well. Let's go back to the modules. We're almost done with looking through Canvas. Let's see. My website is not particularly useful. It's got my office hours on there and class times, and maybe essentially occasionally I post a handout there just so other people have access to it, but usually Canvas is where I post things. I will also post the class recordings and the written notes from class. So whatever I write here, I will also upload to Canvas so you can see it again if you feel like you missed something or it was hard to read. Also, on that same note, my penmanship is mediocre at best. So if something is unclear, like is that a 4 or an 8 or a 2 or a Z, just ask. I'm not offended. I know my writing is just fine, but nothing beautiful. So I'm always happy to clarify. Here's some stuff that's not visible yet, but some final exams from last quarter. Here's some links for graphing. There's some 3D graphing in Desmos, 3D graphing in GeoGebra. And then we talk about graphing phase planes, when we start talking about nodes and spirals and all that good stuff and solving linear systems of differential equations, which sounds fancy, but it's really not that fancy. If you know how to find eigenvalues and find eigenvectors of a 2x2 matrix, which everybody was supposed to have seen last quarter, but definitely, even if you didn't, we will certainly see it this quarter. That's all really what most of it breaks down to, is solving these systems of linear differential equations, just finding the eigenvalues and maybe the eigenvectors of these 2x2 matrices. And then something I was hoping everybody would get to see, but maybe didn't, was this handout I posted to do over the break. So maybe not many of you got to see it because it's on Canvas and we're having some Canvas issues here, but I made copies of it. So just copies for everybody. I would encourage everyone to do this when you have a moment. If there are problems, they're kind of really just giving us, oh my gosh, maybe I could just hand this to you. You can talk to me. Thanks. What else? That's about it as far as that stuff goes. They're mostly questions about like graphing lines and circles, finding domain, mostly finding domain. Yeah. Which we'll talk about maybe a little bit today as well. Yeah, Canvas. All right. Yeah, I got to figure out what's up with Canvas. But I should ask, do you all have any questions about anything I've said or anything I could say more? Thank you. Did you guys do any math today in class? Yeah. What did you guys talk about in class? And it's like, okay, cool. Domain range, right on. Before we get started, let me see if I remember any. I know a few names: Lux, Clarissa, Nick, but I don't think I know any other names. So what's your name? Emily, Brianne, Sophia, Veronica, Nick. Oh, 2 Nicks. All right, Nick. Great. All the Nicks are here, and then we have, I already forgot, Sophia, Clarissa, Veronica, Emily. Oh, started with an A. Brianne, not even close. The next letter, Brianne. Brianne. Okay, Brianne. All right. Try and remember the names. Takes a couple weeks usually to really feel like I know most everybody's name. Domain and range. Oh, I had some notes there myself too. Let's see. Domain and range. Yeah. Cool. Depends. Let's talk about domain and range. Let's talk about domain. Range is less important. Well, that's not true. Range is important too. Let's talk about domain for a second. Ooh, I don't love how far away. There's too much space here. I know it's not a lot of space here, but like this is kind of a lot right here. I don't love that. Oh, you can't see what I'm doing. So if I'm doing something stupid, like James, just tell me. I'm like, James, we can't see what you're doing. Or if you can't see the thing I'm writing because I've gone off the page, just let me know. Sometimes I don't always see the things I'm doing, which is fine. Domain. So very kind of broadly, the domain things we're going to see in 17C are going to be very similar to what we saw in 17A. Well, come on in. Just with kind of, well, literally an added dimension. So for example, in 17A, you might have asked something like, what's the domain of this function? F of x equal to, I don't know, something like 3 over 2 minus x. In this case, well, we know we're not allowed to divide by 0. So we say, well, we can't have a 0 in the denominator, meaning we have to exclude where the denominator is equal to 0. In other words, where x is equal to 2. The way we write that using interval notation is the set with everything except for 2. So everything from negative infinity to 2, exclusive, and then everything from 2 to infinity. And definitely, when I think of domain for functions of one variable like this, I think of just whatever I have on the number line, or whatever I have on the x-axis. Right? If I was going to graph this function, it would look something like something that had a vertical asymptote at 2. And I don't know, my y-intercept would be 3 halves. Yeah, 3 halves. Yeah, 3 halves. So do something like this. And then something like this. So you can see that our domain is literally every possible x value we can plug in, which is everything except for 2. But all the rest of that x-axis or all the rest of that number line are included in our domain. Let's do one more in this kind of function of one variable sense, and then we'll move on to what we're actually getting to. Also, feel free if you have questions or clarifications to ask them. I try to remind myself, like what it was like to learn this stuff once upon a time, but unfortunately, as teachers teach things more and more times, they tend to forget how hard it was the first time, which is definitely more true of a lot of your actual professors. So we try to remember, oh yeah, this was not always something that was just like that. It's not always obvious. It's not always easy. When we're talking about domain, I think of there being 3 things to think of. Either we don't want to divide by 0, or the other thing we often encounter is not wanting to take a square root of a negative number, or really not wanting to, but not really being allowed to and getting a real result. So for example, we could also ask, what's the domain of the following function? F of x equal to the square root of, sure, let's go a little more interesting. Let's go 16 minus x squared. So here, instead of saying the stuff underneath or in the denominator can't equal 0, here the stuff inside the square root has to be non-negative, has to be greater than or equal to 0. So we're going to typically start with saying we're going to set whatever is the argument of the square root function there to be non-negative, greater than or equal to 0. Now, unfortunately, when you're solving a non-linear inequality like this, it's not linear because you have x to a power other than 1. You can't really just isolate x. You kind of could here, and it might work out if you are paying attention. But really, typically, once you have things that are nonlinear, the better choice or the more effective choice is to try and factor. You want 0 on one side, that's usually good. And this other side, we're hoping we can factor. And I can factor that as 4 minus x times 4 plus x. I don't want to be super clear, though. It does not factor as x minus 4 times x plus 4. If you do that, x minus 4 times x plus 4 is equal to x squared minus 16, which is not quite the same as 16 minus x squared. It's actually the opposite or negative. And then I would use a number line. That's almost always how I would solve an inequality, by using an inequality as a function of one variable. Is by using a number line, putting the zeros of this inequality on there. So x equal to 4, and here x equal to negative 4. And then for each of those 3 intervals, testing a point to see if the whole expression here is either positive or negative. So I pick a number larger than 4, like 7. 4 minus 7 is negative. 4 plus 7 is positive. And a negative times a positive is negative. Or pick something between negative 4 and 4, like 0. 4 minus 0 is positive. 4 plus 0 is positive. And a positive times a positive is positive. Or pick something like negative 6. 4 minus negative 6 is positive. 4 plus negative 6 is negative. And a negative times a positive is negative. If I want this expression to be greater than or equal to 0, I want the positive parts. Well, I don't just want the positive parts. I want the positive parts and the parts that make it equal to 0. So here my domain would be everything between negative 4 and 4 inclusive. So bracket negative 4 to positive 4. And then just for the sake of completeness, since we've talked about the first 2 things, either having potential division by 0 or possible square roots of negatives we're trying to avoid, the last thing that we have to avoid is when you take logarithms of things. When you're taking a logarithm of something, the argument has to be not just non-negative, it has to be strictly positive. So you can't take the log of a 0, you can't take the log of a negative number. So for example, if we wanted to find the domain, we'll make this one a little bit easier, of say g of x equal to the log base 3 of x minus 9, all I would do is start by setting the argument to be strictly greater than 0. So we're going to set x minus 9 to be greater than 0. Since this one is linear, right, I only have an x to the first, I don't have any other powers of x, I can just isolate x. Say x is greater than 9. And then if we're using interval notation, that's going to be parentheses 9 to infinity. That's our domain. When I'm looking at these domains, I'm kind of thinking about, well, if I pick a number in this domain, like if I pick the number 12, can I take the log base 3 of 12 minus 9? Yeah. Log base 3 of 3. Actually, that's too easy almost. Log base 3 of 3 is just 1. But I can pick any number. Like if I pick 13, 13 minus 9 is 4, and log base 3 of 4, although it's not a very nice number, it's still a real number. I can take the log base 3 of 4 and get some real output. Similarly here, if I pick a number between negative 4 and 4, like 2, 2 square root is 4, 16 minus 4 is 12, we can take the square root of 12. It's not, again, it's not a nice rational number, but it's still a real number. So now we're going to extend things to functions of 2 variables, which means the domain is going to be a set of points in now 2 dimensions instead of just a set of points along the number line or along the x-axis. So here, for this one, it was all these points. I guess I could draw this one too. For here, we started at 9. It's all the points to the right of 9. So if you were trying to draw a picture for the domain, this is what I would draw. Everything between negative 4 and 4, everything to the right of 9. And the reason I'm pointing to that is because we are going to draw the domains for functions of 2 variables. It's kind of it's not the only way, but it's really the best way of depicting what the domain actually is. Let's look at some examples. Let's start there. Sure. Let's say my function f of x comma y is equal to, sure, let's start with that. 1 over x squared plus y squared minus 25. Well, just like before, when we had a fraction with the denominator, we wanted to exclude all points that made the denominator equal to 0. The same thing is true here. We want to exclude where x squared plus y squared minus 25 is equal to 0. Now I can think of a few points that satisfy this equation. Here's one of them, 5, 0. If x is 5 and y is 0, 25 plus 0 minus 25 is 0. And I bet you could come up with a few more, like 0, 5, or -5, 0, or 0, -5, or even 3, 4. The list goes on. In fact, the list is infinite. There are an infinite number of points that satisfy this equation because there are an infinite number of points that are on this circle, right? X squared plus y squared equal to 25 is the equation of a circle. This is a circle centered at the origin with a radius of what? Anybody? Show me on your fingers. What's the radius? Yeah. Yeah. Radius of that much. So what that means is every point on that circle is not in the domain, which is super annoying. How would we draw that? Well, that means any other point is good. Good being in the domain. So here's how you draw this. We're going to draw the circle of radius 5, but we want to not include it. So when you want to not include something, you draw it dashed. So here's my dashed circle of radius 5. All the points on the circle are not in the domain. 5, 0, 3, 4, -5, 0. The list goes on and on and on and on. And then every other point in the entire XY plane is in the domain. So we usually shade that in. So if I was shading that in, it's kind of annoying, but you, right? It's everything. Everything outside of the circle and everything inside of the circle. The only thing we're not getting is just the circle. Unfortunately, there's not really a very nice way of writing the domain. We can't just use interval notation. There is no interval notation for this. The best way of writing the domain, which usually people in 17C don't have you do, but if you really wanted to actually write the domain, here's how you would do it. It would be the set with using a curly brace of all points x, y, such that, that's what that vertical line means, such that x squared plus y squared doesn't equal 25. We want every point except for the ones on the circle. So that's how you write the domain. But really, we care more about drawing the domain because that's more informative. Questions so far? Okay, let's change it up just a little bit. Also just something to, well, no, we're not quite there yet. So there's always a problem of wanting to say too many things at once. That's my problem, not your problem. Okay, let's look at the next example, which is going to be similar but different. Let's say we have now g of x, y equal to the square root of the same thing, x squared plus y squared minus 25. Yeah, I like that one. Do I like that one? Yeah, I do. Yeah. Sure. Maybe I wanted to go a different direction, but I didn't. That's all right. All right. So just like with the previous square root function we had, or any even root, right? It could be a 4th root or a 6th root or a 1000th root, or you could even write it as a power, right? This is the same as saying x squared plus y squared minus 25 raised to the 1/2 power. Whenever you have an even root or an even or I should say an even fractional power like this, you have to have the insides being non-negative. Right? We can't take the square root of a negative number. We can't take the fourth root of a negative number. At least, well, I should be more specific, without getting an imaginary result. The reason I point that out is because we are going to deal with imaginary numbers this quarter, right? Definitely when we start finding eigenvalues of matrices, sometimes they will be complex, aka imaginary. And that's going to mean a certain thing. That's going to actually, what's really going to mean is when you have your solution, it's either it'll be a spiral if you have complex eigenvalues. It'll be not a spiral if you have real eigenvalues. That's where it's going to come up really for you all. It's not that big a deal, but it is in your future. So you want to make sure you're getting comfortable with the idea of, oh yeah, we're going to use imaginary numbers, and that's just going to be a thing we're going to do. But here, when you're talking about domains of functions, the domain, it's implied that the output has to be a real number, not an imaginary. So here, we still want the insides of the square root to be greater than or equal to 0. Most of the time, when you're dealing with functions of two variables like this, and you're trying to figure out what the domain is or the range is, if you see an x squared plus y squared, you want to isolate it. But you want to keep them together. So if you have an x squared plus y squared, they go together, move everything else to the other side. So I'm going to rewrite this as x squared plus y squared greater than or equal 25. And then I'm going to kind of ignore the inequality part for a second. I'm going to say, well, what if I just pretended like it was x squared plus y squared equal to 25? I know what that is. What is that? I know you all know. I just don't want to say anything, but it's a what? I can't hear you. Oh, thank you. I can hear you now. Okay, yes, it's a circle. Circle of radius 5, centered at the origin. Real quick, just so everyone's on the same page. What about this equation I'm writing here? X minus 3 squared plus y plus 1 squared equal to 16. Is that a circle? Where is its center? In fact, why don't you all write it down real quick? I want you all to write down where the center is and what the radius is. I'm not going to look, but I do want you all to write something down. Yeah, Canvas. I think almost everyone's written something down. Okay. So the center, people either get this right or they get it backwards typically. Center is the x coordinate is positive 3, the y coordinate is negative 1. I always think about it as the numbers that if you plug them in would give you 0 on the left-hand side. 3 minus 3 is 0, negative 1 plus 1 is 0. The radius is the square root of 16, which is 4. Fun fact, the center actually isn't a point on the circle. The center doesn't satisfy this equation. 0 squared plus 0 squared equals 0, which does not equal 16. The center is still important and definitely worth noting, but it's not actually a solution to the equation. So here, if I'm thinking about this, I have a circle centered at the origin, right? Because x minus 0 if you want, and y minus 0 if you want, each of them squared. And then the radius is 25, just like it was before. So when I start drawing my domain, do I want to include my circle or not? I definitely do, because the equation says greater than or equal to 25. I definitely want all the points on the circle. Unlike previously, right? This time I want 5, 0. I want 3, 4, because those points satisfy the equality part of this inequality. I'm not going to mark it off. I'm just going to draw a circle and pretend like I know the radius is 5. I might label this point here as like 0, 5, and this point over here is like 5, 0. Okay. In the previous one we did, we wanted all the points that weren't on the circle. Here we want all the points so that x squared plus y squared is bigger than or equal to 25. What that usually ends up meaning is you want one side of the boundary. You either want everything on the inside of the circle or everything on the outside of the circle. Or if it's a different shape, everything above the parabola or everything below the parabola. Or whatever the border is, you typically want everything on one side of it. Unless it's a straight not equals like the previous problem. So here, I don't know which side I want. So I'm going to test a point. I'm going to test a point that is obviously in or obviously out of the circle. Let's test the point 1, 0. So if I test the point 1, 0, and I plug it into this inequality, I've made the choice that it's going to be wrong because I wanted to show you. 1 squared plus 0 squared is equal to 1. And is that bigger than 25? Definitely not. So since the point I picked is not satisfying the inequality, the point I picked is not in the domain, which means every point on this side of the boundary, meaning every point inside the circle, is not in the domain, which means the other side of the boundary is our domain. If you pick something here like 6, 0, it would satisfy the inequality. So if I try to draw this, it's going to be everything outside of the circle, including the circle itself, because the boundary is definitely part of the domain here. There's my domain, the entire XY plane, except for the stuff inside the circle of radius 5. How would you describe that using words? Probably literally using the words I just said. I would actually write out those words. My domain is all points on and outside of, can I spell? Not really. Outside of the circle of radius 5 times the origin. There's probably not a better way of describing it unless you want to use the set builder notation like I did in the previous example. You could also write it as the domain being the set of all points x comma y such that literally the inequality that we just used to write it in the first place. X squared plus y squared is greater than or equal to 25. Okay. It's time. Oh, we should talk about range, I guess, too. Do you want to talk about range for this one? No, not really. It's not great. Sure. Let's look at a couple more. We have what, 7 minutes? We can squeeze in an example or two. Yeah, let's look at this. Sure. Let's look at 2 more examples. Have you talked about level curves yet? No, probably. Okay, cool. It's fine. I want to say all the things, but also I want to not get too far into the future here. So let's look at the function f of x, y equal to 1 over y minus 2x plus 3. Just like before, we've got a fraction, the denominator can't be 0. So I don't like writing y minus 2x plus 3 not equal to 0. I just don't find that nice to look at, but it's fine. You can totally do it this way. And then I don't have x squared plus y squared. So if I don't have x squared plus y squared, the next thing I look for is I should isolate y. That is usually my thought process. If I've got x squared plus y squared, try to keep those together. If I don't, or if I have negative x squared minus y squared, then bring them to the other side, make them plus x squared plus y squared. If I don't have that, then I try to isolate y. So I'm going to isolate y here. I'm going to get y not equal to 2x minus 3. Or as I would have preferred to have said, exclude y minus 2x plus 3 equal to 0, aka exclude y equal to 2x minus 3. So I'm excluding the line y equals 2x minus 3. This line has a y-intercept of, if x is 0, y is going to be 0 minus 3, which is negative 3. Has an x-intercept of, if y is 0, then x is going to be, let's see, 0 equals 2x minus 3, 3 equals 2x, x equals 3 halves. So my y-intercept is negative 3, my x-intercept is 1.5 or 3 halves. And then I'm going to be smart. I was about to make a tiny mistake. I was about to draw the line solid, because that's how I would usually draw a line. But I know I want to exclude this line, so I actually want to draw it dashed. So I'm going to draw this line dashed to the best of my ability.
trying to make it straight. I do appreciate having a straight edge. Nice, that's not that straight, but fine. And then those are the only points I don't want. Everything else is in my domain. There's my domain. Almost every single point in the XY plane, except for the infinite number of points that are on this line. Oh, look, infinity minus infinity is still a lot of points. Yeah. Versus, let's say we want to explore what the domain of, say, G of, yeah, we'll come back. Welcome, Co-17C. Here for Co-17C. Let's say we have the function g of xy equal to log base 2 of the same argument, y minus 2x plus 3. So, very similarly to the square root one, we have a function where the argument has to be strictly greater than 0 now. So we're going to start off by saying I'm going to set, and I guess I should, sorry, I'm talking about, I didn't write words. We're finding the domain of the following. We're going to set the insides to be strictly greater than 0 this time. Because again, we can't take a log of 0, but you can't take a square root of 0. It's 0. So then I would do the same thing. I'm isolating y, meaning y to be greater than 2x minus 3. It's still the same graphing procedure, right? I'm still graphing the exact same line, although this time I'm going to graph it, well, not any different than last time. This time I'm also going to graph it as dashed because it's not a greater than or equal to. If it had been a square root of all this and had been greater than or equal to, then I would draw it solidly to include it. So I'm going to graph the same line. I'm not going to worry too much about the details. Try and make it look nice. There we go. I might label it. There's my line y equal to 2x minus 3. And then which side do I want? Test a point. I'm going to test 0, 0 because it's clearly on one side of the line. So I plug in 0 here. Is 0 greater than 2 times 0 minus 3? Yeah, it is. 0 is definitely bigger than negative 3. So 0 is the origin 0, 0 is a point in the domain, which means everything on this side of the boundary is my domain. And nothing over here is in the domain. Kind of neat that it always works out that way. The boundary always really is a boundary. You usually want everything on one side or the other. Unless, of course, it's a not equals like this. Then you typically want both sides. And you only want to exclude the one thing you're graphing. Most of the time, you don't see not equals domains like that. 2 minutes. I don't think we need to try and squeeze anything else in that valiantly.